Hello YouTube viewers, welcome to my channel Science to Technology. In today's show, Computer Wednesday, we're gonna talk about computer aided designs or CAD. So let's dive right into it. First, you have to understand this. I have recently acquired a 3D printer, so CAD has become much more important to me than previously, so to say. So what the heck we are talking about here? CAD, what the heck it is? You have to understand it. Before we build anything, before we print anything, before we machine anything, we generally design it. You don't just go YOLO on it. You generally have to do something, especially if something big, important, or expensive. Generally, people design it. Like be it a steam locomotive or be it a Saturn V rocket. People generally spend serious amount of time designing it. Planes, jet engines, whatever have you. Somebody sits down and is like, okay, let's lay it out. What the heck we gonna do? So we generally start with paper and rulers, and we can go very far. I'm like, heck, we landed on moon based on that technology, so you can understand that it's quite capable. However, the reality started to come in is that we are iterating much faster, because any of you have any experience with any sort of development or basically manufacturing is like, dude, every Tom Dick and Harry, you have to keep iterating it. You have to keep iterating it. For example, like I wanted to basically, this is my TV, but I have a monitor, and I wanted to, for live streaming, I have to mount a mobile phone here. So I had to make a clamp that allows a basically tripod leg, something like this, to clamp here. Now I basically have a 3D printer, so I was like, okay, I'm gonna design it. I designed this first. Just this was a profile just to test it. It did not work very well. And then I made it a second one. Okay, now it works. The profile works. And then I designed a full scale one, and I'm like, okay, this is supposed to work. This one, it does work, but problem is it tips over. So third time I had to, like, fourth time at this point, I had to punch a hole here, so that will print out, and I have the ability to put a string there to tie it down. So you can understand, iteration is inevitable. And it was common also for like a big steam locomotive, where the design drawings were like literally in feet. Basically the white paper they were using were in feet. So the whole idea of CAD is basically you still design it. It's not computer is building it for you. It's still you do the work, but computer aids you. Certain benefits you get if you are using computer. Let's say, for example, in my case, I had to change a dimension. If I had to do something like that on paper, basically throw away that whole paper. You cannot just technically erase it cleanly enough and be like, okay, other things are not messed up now. So you can understand the iteration. This paper is like, no. Now it's still better than throwing away metal away, so people are like, yeah, let's burn through paper rather than metal. So it's better, but computer is like, I can do even better. So nowadays, even if you are designing something very small and insignificant, like a small pipe clamp, you will design it on a CAD, and you can fine tune it to your heart's desire, because again, it's free. So that's the whole point. Computer aided design. You still are the designer. Computer is just helping you. Computer is giving you tools that helps you. It's like, hey, be more flexible, be more creative, because while it is true you can design a lot of amazing things with pen and paper, you can't design a Raptor engine. You can design a Falcon, basically F1 engine, Rocketdyne F1 engine, but not a Raptor engine. So because we need so much quick iterations, computer became an integral part of us. Now what about the users of it, the CAD thing? Well, flat out, everything uses it. Flat out, if you put your hand on any manufactured good, there is a very good chance, why I'm saying good chance, there is a guaranteed chance it has been put in somewhere in CAD. So like, I touch this TV, I touched a table here, everything is manufactured in CAD, flat out, everything. So it is at this point in time classified as backbone tech. It's not something like, we don't think about electricity too much. We don't talk about like, do you have electricity? We talk about, hey, do you have good internet access? Because again, we assume by default that you have electricity. Same way CAD is like that in engineering. It's like, we assume that, like, let's say you are an engineer who's like, I'm gonna design the best car engine, and you did work for your own shop, basically own your small garage. You made a, like, old school, you designed one giant engine, and you have engineering degree and all that. You went to a car manufacturing company. They will assume you know CAD. They don't care whether you did it on by hand or not. They will assume that you have CAD, because while it's one thing to design one engine block, when you have to design hundreds of them, you can understand that part. So it's a backbone tech. People have to know this one way or the another. It does. Software can change, software package can change. You can go from free to ludicrously expensive. That's not an issue, but you have to know CAD. So you have to know engineering, production, all of them are running on CAD. Then we come to art also. It's no longer just like, okay, somebody is designing. There are many architecture who design small art pieces, mechanical art pieces, where we have concrete, steel, things of that nature. They are still designing it in CAD. Why? It allows you to iterate very quickly, much quicker than paper. So people are doing that. And then we come to architecture. Architecture is recently, because we are selling like a building that has not even been built yet. So how the heck you gonna sell customer? Like, yeah, this plot plot of land, there will be a big building and some floors. And nah, you have to show them this. Heck, this technology has exaggerated to such an extent. My friends are working in this. It's like they have the CAD design and then they port it into game engine, and they are developing a VR walkthrough. So basically, customer will wear the VR goggles and they'll just look around how the heck everything feels. Much better experience, so to say. And when I say cats are like some things, design big things, you have to understand biggest thing so far still would be built in cat. Basically from fighter jet to fighter aircraft carriers will be built in basically cat system. The biggest example I know of is that Boeing or Airbus wanted to build a factory for one specific aircraft. The reality was they needed to redesign it properly because the orders they were getting was way too high. So they're like, okay, we have to design a factory. Like, okay. So they bought the land and they started the CAD modeling. It took them 2 years. 2 years just to lay down the factory before they even started a production. And it was like a huge building, like those buildings which have climate system inside. Basically they have cloud formation inside, those kind of buildings. So you can understand it's everywhere. CAD is no longer a luxury some big companies use. No, no, no. It's not like carbon fiber. It's like metal. Every Tom, Dick and Harry uses. So if you are engineering or if you are doing electrical works or anything like that, you have to use this. Now, what is the logic behind this? Let's say you think about computer design. So you know for a fact that 3ds Max, Maya, animation, game development. I used to be game artist, so I know these 3D words. But what is the difference between that 3D, basically 3ds Max, Maya, Blender, and all that, versus Fusion 360 and Tinkercad and SolidWorks? What are the difference? These two technically look the same, and like if you don't know what you're looking for, both of them will literally appear the same. So what's the difference here? Well, the 2D the system, basically the CAD world, is designed for accuracy and precision, because you have to understand we are building parts. These parts have to be mass produced many times. So they were like, okay, this is the design of it. You cannot have there was a variation in 1 millimeter and now the screw no longer fits or it breaks too quickly. Yeah, you did if that happens. So for this reason, precision on these equipments are much higher. The software package, it is like more closer to vector based graphics than pixel based graphics. For example, if you are familiar with the image world, there is two majority format. Basically you have vector, which you can zoom in as much as you want, they will never break down, and then you have raster images, basically photographs, pixel based things. So raster based is 3D world where you have polygons, vertex, tricounts and all that. But CAD design, they work on basically vector based system. So there is a mathematical model there. Basically this circle is not small polygons, it's a mathematical drawing. Now it will draw that for a software, it will draw that, and then computer will paint it out and then it will shade. And many times people, when they are exporting this to 3D printers, they do make the mistake of low poly transmission, and then you will see triangles in basically printed part. That's poor operator error, but not because of the software will never have those things. So inherently it's completely different. And how the heck you model it? You start with 2D. The reason for that is most of the things generally start with 2D. For example, right now one thing that is very popular in this world is 2020 aluminum extrusions. They are quite basically they are Legos for grown-ups, and they are quite amazing. People build from like small things like table, chair and all that, to CNC, to plasma cutter, to rocket engines. Rocket engines, I went a bit far, but you get the point. It's like rocket engine test stands have been built on this, so you can understand that. It's very capable. But how do you design? You design the main extruder and just extrude it. You design the 2D and then you extrude in third dimension. So that's how you get the control aspect. Another aspect is adjustability is very crucial here, because if you're designing a part, how would you know whether it works or not in real life? Or let's say you designed a part, you send it to the engineering department, they took your design, they manufactured it in lathe, CNC machine, whatever have you, and they're like, okay, this works but it breaks here, now you have to reinforce it. So like, okay, that's the whole point of CAD nowadays, because I specified computer aided. The luxury is you can change a parameter. Basically when I was modeling this, I had an issue where a ribbon I drawn on this was in the incorrect place. No problem, I just moved it. It's simple. Sometimes it's like, yeah, that hole is too tight for my nut. It's like, okay, I'm gonna exaggerate it. It's very easy, adjustable. It will not break my other dimensions. And there is another bigger brother of CAD system, which is called CAM options. Now CAM is computer aided manufacturing or computer aided machining. Basically if you have to send data to CNC machine is not gonna see this 3D model. It's like, I got this, I'm gonna model it out now. You have to have a different piece of software. Same goes in 3D printer. 3D printer generally calls this slicer. So slicer is a CAM options. Fusion 360 has slicers built into it. It's a very recent addition. So you can go from design box to manufacturing, and then you will have additive. You can have your slicer settings, and this also gives you drawing. Simply reason for that is if you built it, you designed it, you manufactured it, it's like, okay, this works. Most likely you will not be the one who's gonna make millions of them. You're gonna send it to some company or OEM manufacturers like, bro, make millions of these. So for those people you have to make a design again, so they can figure out how the heck they're gonna make plastic injection molds and all that jazz. So drawings and basically CAM options are available in CAD software. Not every software has this, not every software have good options in this, but it's a tool that is there. It's also aids into design process. So let's say you are like, okay, I got this, CAD is serious, CAD is important, from 3D printer to CNC machine to laser cutter to plasma cutter, blah, 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 it's everything uses. Okay, we got this. So how can you start? Let's say you want to have something, a tool, and you are capable enough in yourself where it's like, I can learn tedious software. I would suggest free CAD. Reason for that is 100% free and open source. It's basically like VLC. And while the software is not as polished, heck, it's not even in version 1. They are still at like a 0.8 version, and they specified as a beta level, but it's a CAD software. Like, it's a high level CAD software, which means you can run your whole corporation on that, basically using free CAD, and it runs on Linux also. So you can have a truly independent system where you're not paying a lot of money for the software department, because again, SolidWorks, Fusion, actual CAD softwares, those are ludicrously expensive. They're like on a different level. The expensive money that you are talking about is like, computers will start to look cheap when you have integrated graphics, or Quadro graphics card will start to look cheap. So if you know yourself and you want like something totally free, totally open source, free CAD is a good option. Then let's come down to more general public. Is like, hey, I just bought a 3D printer and I want to explore the world, I want to design parts and all that jazz. Generally Fusion 360 is the best option, even for CNC, all that, simply because, again, same way Adobe is a huge name in 2D world, from Lightroom to Photoshop to Premiere to After Effects. Like, you don't talk about Adobe because it's like, it's everything, everybody else is there. It's like, nitrogen in the atmosphere. It's like that. In 3D world, Autodesk is like that. Autodesk is like admin there everywhere. The only software that was even capable of competing against us was Maya, and they bought it. So you can understand that flat out Adobe is the reason Adobe does not buy any 3D package is simply because they cannot compete against Autodesk. Autodesk is like, king in the 3D world. Whether you like it or not, it does not matter. They are king. And there is only one other software that in computer aided modeling world that is independent. It's SolidWorks. So SolidWorks is very successful and popular, and if you watch Hacksmith, he is constantly utilizes this tool. So Fusion 360, the benefit of that is very free for students and hobbyists, especially if you're not making a lot of money. It's completely free. Side effect, again, it's basically Autodesk, they can directly remove that option, or the fact that you have to understand this is cloud operated system, so all the file you are creating goes into their cloud. Benefit, you can run simulations, and you can run simulations on their cloud system, because your puny computer barely can run simulations. So these two options are very good for starting. Basically, if you are serious about it, like, dude, I'm gonna become a CAD modeler and like I'm gonna sell my services to people, free CAD is a very good option if you want to be like absolutely free. Then you have other options. Fusion 360 is very good for people who are like, let's they want a much more complete software, because this puppy can design truly powerful things, as in like industrial grade truly powerful things, because they have service support and experience of Autodesk. Then you have SolidWorks, a completely different beast. But you also have to be mindful of that there are many more options. Heck, there is a specific software that are built for laying down PCBs only. So there are more than enough options at this point in time. Fusion 360 and free CAD is very good for starting out. So this was my presentation on CAD. I hope you liked it, learned from it. In that case, please click the like button, share it amongst your friends. If you have watched the video so far, I would urge you to tell me whether you want some tutorials, actual tutorials where I'm going to show you Fusion 360 or not. I would like to listen to that, if you have want to do it or not. If you didn't like it, didn't enjoy it, I would urge you to press dislike, press it twice to show me extra disappointment. Please leave a comment, because I'll try to reply to all of them. Subscribe, press the bell icon if you're free, and as always, thanks for watching.